Alright, so here's our an example. If you watch the previous video, you'll kind of get an overview of how we attack the graphs of these. And now we'll show one, actually, we'll apply some of those rules to figure this out. Okay. The first thing we want to do is make sure our numerator and denominator are factored if it's a polynomial. And in this first problem, this is actually 163 from your homework. We can't factor the numerator, it's just a constant, and the denominator is just a linear binomial, so we can't factor that guy. Right away that tells us that we won't have any factors cancel, so we will not have any holes. So for holes in this graph, there will be none. Okay, the next thing we look for is a vertical asymptote, and that's pretty simple. Just look for what x value makes your denominator 0. In this case, x equals -3. So on our graph, we're going to draw a dotted line there. So there is our vertical asymptote. Next, we'll find a horizontal asymptote. To find the horizontal asymptote, remember we have to look at degree of numerator and denominator. On top here, the degree is 0. This is like 2x to the 0 power, which we always write as just 2. Okay, so its degree is 0. The denominator has a degree of x to the first, so 1. Denominator has a bigger degree, and in that case, it's y equals 0 always. So there's another dotted line on our graph. Next thing we want to do is find our x-intercept and our y-intercept. So to find our y-intercept, let's do that first, it's always easier. To find our y-intercept, we let x equal 0, and if I plug in a 0 for x in this function, I would get 2 over 0 plus 3, which is 2/3. So I'm going to have a y-intercept at 0, 2/3. So there I've marked 1 on my graph, and so 2/3 would be right about there. Next thing I want to do is find out if I have an x-intercept. If I think about this function, I'm running out of room a little bit, so I'm going to write to the right over here. The question is, what will make the y, the f of x, what will make it equal 0? If you think about what x value would make this thing equal to 0, 2 divided by anything will never give you 0. I could make x infinity something very, very large, but I'd still have some decimal value. So this equation will never become equal to 0, so I have no x-intercept. And then the last step, I want to find a few values to help me plot this thing, so I just make a little x and y table. And I could plug in 0 for x, but I already know the answer to that. It's 2/3. That's this point that I've already graphed. I might plug in a 1. It's not going to be very interesting, but that would give me 2 over 4, or a half. So at 1, it comes down here to a half. And because we have an asymptote here, we kind of have a general idea now already of what it looks like. It's going to cut through and get really close to that one, and really close to this one. There's still another branch to this, and so I want to test some x values on the other side of this asymptote, like -4. So I'll plug in -4 into the function, and I get 2 over -4 plus 1, which is 2 over -3. So -4 gives me -2/3. So it's going to go right through about, maybe not quite that point. I marked my 1, so 2/3 would be a little bit lower. Somewhere down there like this. And my asymptotes again tell me now that it's going to sit in there, just like that. And that's what your graph would look like. I can identify the holes. Let me erase some of this work so you can see my answers there. The holes doesn't have any. Vertical asymptote at x equals -3. I've drawn that guy right there. Horizontal asymptote at y equals 0. That's the red line right up there. X-intercept, I've marked that guy. or the y-intercept and x-intercept, there was none. And you can see these blue lines that we graphed never crossed the x-axis, just like we predicted. And that is your first homework problem.